Good morning, grade 10. In the previous time that we were here, we did the linear function, and we're still busy with the linear function. We did on page number 7, and then we looked at the linear function, sketching the linear function by the dual intercept method. All right. Now, just to recap, when we make use of the dual intercept method, we say we're going to determine two intercepts, namely the X intercept. And how do we determine the X intercept? We make Y the subject. Just make the making Y the subject. So what does that mean? That means that we want to get Y equal, we want to make X the subject. That should be X. So we want to make X the subject, and we want to get, so how do we do that? We put Y equal to 0. And by doing so, we get X alone on the one side, and then we solve the equation. And here, we let X equal to 0. And why do we do that? After we've done that, we've put in here X equal to 0, we're doing what? We're making what? We're making Y the subject. Make Y the subject, and what does that mean? We want to get it alone to the one side. We want to end off with Y is equal to a value. Alright, and that value is going to determine the coordinates for the X intercept or whether it's the Y intercept. So that is the dual intercept method, and you could have used that method as well. However, that is a little bit difficult when we are doing once we are doing a one that doesn't have a Y intercept. Alright, so we did also the linear function, and then for homework I asked you to complete the following. To complete number 2. Sketch the graphs of the following linear functions on the same set of axes. That is what we are supposed to do. And like I did in the previous one, I like to go draw myself a table because I prefer doing the table method. They didn't say which method I should use, so I'm going to use the table method right here. So I put in this videos the values -1, 0, and 2. You could have put in more values, but that is the values that I'm going to start off with. And what do? I am simply just going to substitute these values into the equation. Now I can do it in last period that we were here, I did it by hand. So I have an extra piece of paper here to the side where I write out the formula and I substitute the value. I'm also going to do that once again, but I'm also going to show you how to do it on a calculator so that you check your answers and you eliminate mistakes in that process as well. So I'm going to do the order, and let's do the first one, k of x. So the function here is k of x. So I write down k of x. K of x is equal to -x, like that. Alright, what is the values that I'm going to substitute? The values is going to be -1. K of x, so I'm going to say k of -1. And everywhere where there's so I'm going to substitute -1 times with -1, and my answer is going to be +1. But remember, I need to multiply negative times negative, which equals to a +1. And I can check this answer on my calculator as well, because what do I do once I'm on my calculator? How do I do this on my calculator? I'm just checking my calculator. Make sure when you start your calculator, what you can do for me when you go to your calculator, press the shift and then press clear. Alright, and then you clear everything. So if they ask you, you say yes. So that in that essence, you make sure that your calculator is clear and ready. I'm going to repeat that steps. So it's going to be shift, clear, and then you clear everything. So your calculator is ready. You have to do that every time, Cole, before you write an exam. Alright, so what am I doing? I'm saying it's a negative outside. I open my bracket and I put in another negative there, a -1, and then my answer is going to be 1. Okay, so what happens? It's this negative right here that's multiplying in with that negative right there, which equals to a positive. A negative times a negative is equal to a positive. Alright, so now all I have to do, I don't have to do all of the steps, but I can write in my values there. So I know this value is negative, it's 1. This value is 0 because it's a negative times a 0 is going to be 0. And you can check, all I substitute there into the bracket right there. I'm going to substitute into that bracket. What am I substituting now? I'm substituting 0. Alright, so we're doing 0. So 0 is right. I'm just checking my answers. Now I'm substituting. What is the next value that I'm substituting? Positive 1. Bracket. I make sure I close that and I put in 1 there. And then I get my answer is negative 1. So that's negative 1 and that's negative 2. Alright, so what do I do with this? This is my x coordinate, this is my y coordinate. I go plot there. I take a ruler and I go plot these values onto my Cartesian plane. So where's my x? Where my x is negative 1, my y will be equal to 1. So there's my dot that I draw there. Alright, where my x is 0, here's x equal to 0. What will be my y? My y will also be 0. Why my x is equal to 1, what will be my y? My y will be negative 1. Alright? And then where my x is equal to 2, my y will be what? Negative 2, like that. So all I have to do now, I take my ruler and I draw the line through those 4 dots that I drew there. And I just draw, and then I just name him that, what is his function, the name of this function? K of x is equal to negative x. Just like that. Alright, so I'm going to do the rest of the functions, but I'm going to do it on my calculator. I hope you can see the calculator on the screen. So what I'm going to do, let me just pause and clear up the screen a little. Good, we're going to do the next few now, and we're going to do it on the calculator. So my second function is the function that looks like this. The second function is the function that we have m of x. M of x is equal to, so I'm just writing down the function so that I can see it. M of x is equal to negative x plus 1. Alright, so I'm going to put in the values of negative 1, 0 and 1. So I'm going to check there. So I'm going to write m of negative 1 is equal to, now I can do this on my calculator, and I'm quickly going to show you how you do this on your calculator. So all you do, you type in, on your calculator, you type in negative and you type bracket. Close the bracket and then you type plus 1. Alright, because that is the function, this is the function that we're doing. So what is the values, what is the first x value that I'm replacing? So then I type negative and negative 1, and then my value is going to be positive 2. So I write there 2 and I fill it in there. And then at my next value, what is the next value in my year? What is the value that I'm replacing there? Who can tell me? The value is going to be? So now I can just go back on my calculator. I use the arrows and I go back. The d by negative 1, I'm replacing what? I'm putting in 0. So then my answer is going to be 1. So this answer is going to be 1, and then the next one is going to be what? So now I just go back where the 0 is and I replace that 0 with what? With 1. Alright, so I press there delete, and then I press 1. And then I just put in the values there, and that is equal to 0. And then I just do the same with the number 2. I use my arrows and I press the bracket, and my answer there I fill in 2, and then my answer is going to be what? Negative 1. Alright, so what do I do with these, with the tables? This is my x values and my y values, and then I just go plot those x values. And it tells me where x is equal to negative 1, what is my y value? Where x is equal to negative 1, so there is the point that I'm plotting. Where x is equal to 0, what is my y value? 1. Where x is equal to 1, there is x equal to 1, what is my y value? 0. So there is the y value. Where x is equal to 2, what is my y value? What is that value there? Negative 1. So I put that dot right there. And then all I do now is I connect the dots like that. So that was the homework. It wasn't that difficult. You were supposed to do that for me. And then I named the function. What is his name? His name is m of x is equal to negative x plus 1, like that. Is everyone good with that? Okay. I'm going to do the last one quickly. I'm not going to record it, but for purposes of time's sake. So I'm just going to do it with you guys so that you are sure. Alright, so I've completed this now and I've put in my values here. And my values, people, looks like that. And I'm just going to name my function. This function's name is the line p of x is equal to x. It's negative x minus 2, like that. Alright, so I'm just going to put it, and then I'm going to turn over the page. So I'm going to turn over the page, and I want you to read on the questions there on the next side. Alright, so the question states to us, now answer the following question based on the graph, on your graphs. Alright, so remember this graph, so I have that picture of this graphs, and I want you to visualize or take into consideration the following. So we're on the next page, page number 10, and what do you notice about the slope? Another name for the slope is the gradient. Alright, just put in there gradient of the line, gradient, and then number B, what do you notice about the coefficient of x in each equation? And then number C, what can you conclude about the coefficient of x in each of the questions? And then number D, in each equation, number D, what is the y-intercept of each line and what is the relation between the y-intercept and the equation? Alright, so that is the few stuff that we have there. Now, the first answer, I'm going to repeat the question. What do you notice about the slope of each line? We see at the first one that the slopes or the gradients are the same in everyone. So they are the same, and that is the answer to the first one. Okay? The slope or the gradients are the same. And what do we mean about that? Let's just go back to the previous page. So when we talk about the gradient or the slope, it's actually how steep the line moves. So what is the gradient? Is this gradient right here is the same as this gradient right here, and this gradient is the same as that one right there. And even at the first one that we did on the previous period, is this one is the same as this one, and this one is the same as that one. Do you see? So they move. And what is the slope? The slope is actually the horizontal rise over the vertical run. The vertical rise over the horizontal run. Okay? So that is what the slope is. So if we turn the page there to answer the questions. Question number A, the slope and the gradients are the same. Number B, the coefficients are equal. Because what is the question at number B? They ask us, what do you notice about the coefficient of x in each equation? We see that at the first one, all of those coefficients were the same. And if I turn the page there, what was the coefficients of the first one? I'm talking about, what was the coefficients at number 1? No, just check there. The coefficients is this one here. What is the coefficient of x here? 2. What is the coefficient of the x there? 2. And what is the coefficient of 2? So the coefficients are the same. And then they ask us the next question. What is the next question there? So what can you conclude about the coefficients of x in each equation? And the answer there, I want you to write this down for me, is if the slopes are equal, the lines will have equal coefficients of x. So that means, in other words, m of the first one, and m is the gradient. M is the gradient, alright? m of the first line's gradient will be equal to the m of the second line's gradient, like that. So you can copy that for me, just right there. At question number D, what is the y-intercept of each, and what is the relationship between the y-intercept and the equation? You can copy that answer as well if you didn't do it. The y-intercept can be obtained by the c value of an equation in standard form. For example, y is equal to mx. Now m here is the gradient. Alright, remember the first one, it was, what was all those gradients? The gradient was 2. What was the gradient in the second one? It was -1. Look here, come yellow. If we look at these gradients here, at k of x, m of x, and p of x, if we look at these gradients right here, what is the gradient there? It's -1. What is the gradient there of x? -1. And that gradient there is -1. Alright? So once again, the gradients are the same. So what is that gradient? How do I get the gradient? It's actually the m value, m of x plus c. But if there's no c value, that actually means +0. Okay? And then we can say now that the y-intercept can be obtained by getting the c value of an equation in standard form. So that means the equation has to be in this form. Y is equal to mx plus c. Or the other one, which is just different variables we use for m or for c, that is the a and the q. So instead of writing m, they use a of x, and then instead of writing c, they write q. Alright? So that's what we have there. So the c is the y-intercept, and the m is the gradient. Once you've done writing down this or correcting your answers, I want you to go on to the next page. There we are going to be looking at the gradient of a straight line. And we have already concluded that the gradient is the m value. And there we are given the function y is equal to 3x. So what is that gradient there? What is the gradient of that line on page number 11? The gradient is going to be y is equal to 3x. And what is the gradient going to be there? The gradient will be 3. That is the gradient. Alright, so my m is equal to 3. Now consider the point 0. They have already worked out the points. Now, how do we determine the gradients of a point or the gradients of a line? We need 2 points. Alright? So I'm going to show you. Here we are given the point what? 2 and 6. And here we are given the 1 and 3. So, the formula for determining the gradient, and the gradient's name is m. So in the formula it looks like this. This means the difference in y over the difference in x. Alright? So how do we determine the difference of something? So we minus. So what are we going to say? We're going to say the difference. So this formula goes further and it looks like this. It's going to be y of 1 minus y of 2 over x of 1 minus x of 2. And what does that mean? That means I need to take the first y value. Alright? So I'm going to say 6 is the first y value. And then minus the second y value. What is the second y value there? 3. Minus 3. And then I'm going to say over what? Over the first x value, which is 2, minus the 1. And now I simplify. 6 minus 3 is equal to 3. And then 2 minus 1 is equal to 1. So I get 3 over 1, and that's equal to 3. All right? We could have used, so we didn't only have to use this values right here. We could have used this 2 and 6 and that point 0, because that is another coordinate on the line. 0 and 0. All right, let's use m, and we're going to use this coordinate. So we're going to determine what is the gradient. And what did I say? The gradient is actually this, the rise over the run. That means, how much did I travel up or down over how much did I travel left or right. That is actually what the gradient is. So I'm saying, once again, I write my formula. It is the distance or the difference of y over the difference of x. And my formula is always going to be y of 1 minus y of 2 over x of 1 minus x of 2. Are you with me? And then I say, good. Now, what is the first y value? All right. So let's work from here. I'm going to work from the 0. So I'm going to say 0 minus, because this coordinate here is 0 and 0. So my y is 0 there. So 0 minus, what is this value's coordinate? What is the y there? The y is 6 over, what is the x here of, at that point? 0 minus, what is the x value of that one? 2. Alright, remember I'm working with this coordinate right here and that coordinate right there. And now I'm saying, what is 0 minus 6? Negative 6. What is 0 minus 2? It's negative 2. A negative divided by negative is equal to a positive. Alright, so that's 6 over 2, and 6 over 2 can be simplified to 3 over 1, and that is once again 3. You see, the same line is supposed to get me the same coordinate. So you can use any points. But, so what do they tell us further from there? That is just in a quick example. Consider the points 0 and 3. Consider that other points 1 and 3. And then consider the other points. So it's just the change in y values, and what can you conclude about that? We can see that the line has a gradient or a slope of 3x. So how do we determine m? M is called the gradient of a line, and it is determined by the change in y values over the change in x values. Okay, is everyone good with that? I'm going on to the next page now. I'm going on to page number 12, and now this gives us the gradient intercept method. We can easily sketch straight lines using the concept of the gradient y-intercept. And I'm just going to read that again. We can easily sketch straight lines using the concept of gradient and the y-intercept. Example, y is equal to half of x using the gradient intercept sketch method. The y-intercept is 0. Now, why is the y-intercept 0? Because there is no other values additional to this. Alright, so in essence, this is actually just y is equal to half x plus 0. But we don't write down that 0. So the 0 is there. So I know what is the y-intercept. Where will this line cross the y-axis? It will cross the one at 0. So I make myself a dot there. And now I know that the y, for every one that it goes up, it needs to go how many places left or right? Just check there. What is the gradient? It is the difference in y over the difference in x. So for every one that it goes up, it needs to go how many sides left or right? It's 1. How many? What is the gradient here? 1 over 2. Okay. So how many? If it goes up once, how many times does it need to go left or right? Twice. All right. Now if it's positive, the gradient will always go that side. If it's negative, the gradients will go down. And we call this increasing, and this we call decreasing. Alright? Increasing, decrease. So if it's negative, it will be decreasing. If it's positive, it will be increasing. So if I go up, how many times do I have to go left or right? Twice. So 1, 2. And that will be my new coordinate. Alright? So all I have to do, I can draw that line, and I just can connect that dots like that. And there I have the coordinates, or the line of y is equal to 2x. So this is the line, y is equal to a half of x, like that. Alright, so there they give you the sketch. Alright, so example, sketch y. Let's just read through example number 1. Sketch y is equal to a half of x using the gradient intercept method. The y-intercept is 0. Alright, the y-intercept is 0 and the gradient is positive 1 over 2. The positive sign indicates that the line slopes to the right. Alright, to the right. And the number tells us that to rise up 1, that is the one rise that I have, 1 unit, and then the numerator tells us to rise up 1, and the denominator tells us to run 2 units to the right. Okay, so that is just basically what we did in verbal form. They're just explaining what we just did there. Okay, now we look at example number 2. Sketch sketch y is equal to negative a half x using the gradient intercept method. Alright, I just want to see if there's another space for us to sketch that. Alright, so we need to sketch it on this one. The y-intercept is 0. Once again, what is the y-intercept here? 0. So we'll be starting there. And then the y-intercept is 0 and the gradient is negative 1 over 2. The negative sign indicates that the line slopes to the left. So we need to go to the left-hand side. So if we start there by 0, we know the y-intercept is 0. And then I'm going to go how many units up or down? I'm going to go 1 unit up. Alright? Remember, it's negative 1. So it's y over difference of y over difference of x. So I'm going how many units up? 1. Now is the interesting part. Am I going left or right? Left. Why am I going left? Because it's negative. Alright, so I'm going to say decreasing, and now I draw 1 unit, 2 unit. I make my point there, and now I just draw the line between those two dots like that. And this is then the function of y is equal to negative a half of x. I do apologize. And then what is important? You always start with the y-intercept. Alright, so where do we get our y-intercept? Say if this is a half of x plus 2, where would I start? I would first go by my y-intercept, and my y-intercept is going to be 1, 2. So I'm going to start there. Alright, so let's just, for practice's purposes, everyone just see if we can draw that. So y is equal to a half of x plus 2. So where am I starting, guys? Who can tell me where am I starting? I'm starting by the y-intercept. And where do I find the y-intercept? It's the c value. So this is the y-intercept. Okay? I can read it from there. So where's the y-intercept going to be here on the line? I go to the x-axis or to the y-axis, and then where y is equal to 2. Is it here? Upwards. Is it that one right there? So I put in there 2. And then how do I go now? How do I determine my gradient? For every one that for the numerator tells me how many times do I need to go up or down. I need to go once up, alright? And then how many times left or right? 2 times. But which side am I going, left or right? I'm going to the right. Because why am I going to the right? Because this is positive. This is positive. So now I say 1, 2 units. And then I draw my line, and then I just connect those dots like that. Alright. So there I fill in this line's name is y is equal to a half x plus 2. That wasn't part of that, but I just want to make sure everyone got that. Alright, stay with me, guys. Focus here. Let's look at another example. Example sketch. Alright, sketch 4x plus 2y using the gradient intercept method. All right. So what we're going to do, we're going to do this now in class, and then next period, this whole page you do at home. All right. If you don't finish in class, you do it at home, and then we will continue from page number 14 next period. All right. I thank you guys.